Good morning, faculty members, and good morning, students, if there are any attending the session. Uh, it is strongly recommended that you attend the session from your desktop so that you might also learn about the programming bit of it. Yep. Thank you all so much for joining in, and good morning, everyone. I'm sure you all are excited, but before we get started, a quick question. Are you all able to see the screen and hear me? Yes or a no? Please, can you respond to this poll question? It'll be easier if you connect from your desktop because this is one of its kind training on the futuristic artificial intelligence and deep learning. This will be the next step to your regular data science. Okay. 93% of y'all are able to see the screen, and that's a very good thing. Oh, issues you have to check at your end. Okay. I'm using a noise cancellation mic. My internet speed is, let me clarify that once again. So we have a speed test. Let me do speed test once again so that you all see on what kind of speed I'm using so that you don't complain that audio is not good or screen is not clear. Those issues will arise when you use 4G network, 3G network, when you connect from your mobile phones. Yeah, because your mobile data, it depends on that speed. But from our side, we use noise cancellation mic so that there is no resound. Number one. Number two, we use high speed internet connection. High speed internet connection. So absolutely, if you have any issues, issue will be at your side. Please rectify that. Okay. Um, I cannot comment on that, but at least you need to have some good 20 Mbps or so that you do not experience any issues. Dharmachari, probably that helps. Um, yep. So I'm sharing a screen which says, Welcome to Faculty Development Program on AI and Deep Learning. Now, I stopped the sharing because I want to share the complete screen. Why do I want to share the complete screen? Because we should now get started with AI and deep learning. Okay, here we go. We have this mind map using which we will do a recap. And after the recap, I'll spend some quick 5 minutes to again clarify certain things. Okay, now, with respect to the books that you want to read, you can read Andrew Ng. He is deep learning guru. But first of all, you have to focus on this training because I personally would have read at least 100 plus books in the space of deep learning, and I would have at least implemented 50 projects until now. And we are working on products. So all that experience is something that we are bringing here. And don't please be books oriented. Otherwise, again, we will not contribute to the society in terms of bridging the gap between industry and academia. Academia is more books oriented. The reason why AP State Skills Development Corporation has requested us to conduct this session is because there is a gap between what industry needs and what academia teaches. Once again, if you're books oriented, we are simply not going to fill this gap. To fill this gap, we need practical real world experiences, practical use cases, not the textbook use cases. We need practical use cases. Okay, and only then the gap will be bridged. Otherwise, it'll be once again the same. For the next 100 years, we will keep saying that industry needs something else and academia teaches something else. Industry needs practical data scientists, practical AI experts who can readily work, but colleges and universities are still, bringing out students who are books oriented. Read books, that's it, don't do anything. Then why should a company hire, right? So we are here with AP State Skills Development Corporation to bridge the gap. So we should switch towards practical applications, practical. If we can make our students practically rich, they will automatically get a job. I keep saying this, that rather than giving a fish to a student, teach him how to fish. He will survive for the rest of his life. If you just are going to impart bookish knowledge, we are not doing justice to their lives and to their careers. And if it's only book oriented, people will not even find it interesting, right? So hence, let us put full stop to the books. Let us get into the practical world, and practically we are going to learn it. Hence, we are explaining about this project management methodology because we don't want our faculty members to be textbook oriented. We want them to be practical oriented. Yep. So this is one thing which is lacking in the industry. When we interview people, students, we ask them on, okay, you say that you have worked on this project. Can you explain on how you have actually started working on the project? And immediately they jump into the algorithms and they say that, do you know what, this was a problem, I implemented these kind of algorithms. No interviewer would be impressed. First of all, there has to be a structured methodology in handling projects. And that structured methodology here happens to be CRISP-DM, which stands for Cross-Industry Standard Process for Data Mining. The first step as part of this is to understand the business problem. And once you understand the business problem, you need to record business objectives and business constraints. Once you record your business objectives and business constraints, then we move to the next step. What is the next step? Next step is data collection. As part of data collection, you have primary data collection and secondary data collection. Though the name says secondary, the first importance, or you just go after secondary data set first. Okay, you get the data from secondary data source. Why? Because the data is already available. Just go take the data, proceed further with your analysis. If you do not have the data needed for your analysis, then we resort to primary data collection mechanism. Okay, then we resort to primary data collection mechanism. Primary data collection mechanism includes surveys, experiments, web scraping, social media extraction. Still, a few of our faculty members are saying that we don't have Facebook account, we don't have LinkedIn account. It's a humble request. And on a serious note, if you do not have accounts, then you will not be able to train your students on social media analytics, which is a very big thing. Very, very big thing. Then your students will become substandard once again. So in order to train your students, you also need to be having an account, you need to know what options exist. For example, there is something called as Facebook developer app. Until and unless you have a Facebook account, until and unless you create your developer account, you will not be able to use this. And look at this AI, augmented reality, virtual reality, open source. These are all the developer tools which we will end up using. My dear faculty members, please, this is a humble request from my side. You are going to become probably a tutor or a professor who has only limited knowledge. If you don't have account, you need to know all these things, because we all are teaching on emerging technologies now, right? So please, again, I request, please do not post any message saying that I don't have an account henceforth, because not having an account is a bad thing. You need to have. You need not always be active on Facebook and LinkedIn, but at least you need to have to explore the basic options. Even for that case, if you take Twitter, you'll have developer accounts. But until and unless you have a Twitter account, how will you enter into this? Right? And you need to have this, because there is a lot of APIs which you have to use to get the tweets, to analyze the tweets. Even for that case, Narendra Modi tweets on Twitter, friends. Our prime minister of the country uses Twitter and social media actively. And why can't we use? Right? So please have that account. It's a humble request once again. Without that, you will not be into the next world. You'll be in the old generation only. Let's not get into that, right? Please. All right. So, in order to collect the data, you need to first of all understand about the various data types. And today, we will spend ample time on the various data types and proceed further with data cleansing. And I'll explain about data mining. And then I'll also do a recap on whatever we have discussed yesterday. Yep. Having said that, there is yet another thing that we need to do, which is the quiz. A lot of people have responded to the quiz on WhatsApp. I don't know what to say now, right? But I request, please, you all to put your answers on LinkedIn or Facebook. Not having account means maybe you need not take the quiz. That's okay. But then again, the caution is social media extraction is a very big thing. You do emotion mining and all that. If you don't know how to use an account, then you'll not be able to teach any of your students. I'm sure you all will respect this thought, and please do not have any second thought on that. All right. So these are the various people who we have for now considered everyone who has responded on chat messages also. But from tomorrow, I mean from the next session, we will only consider social media comments as final. Okay, so by then please have an account. It will take 2 minutes to create an account. And how many do we have? 543 people. For all these 543 people, I first want to say thank you so much for contributing to the quiz. We really appreciate. But then we have Google random number generator, or just let me type random number generator. And we have 543 people. How does this work? This works in this way. When I click on generate, randomly it chooses a number. And I'm sure you all are aware of the probability formula. Formula of probability is number of interested events divided by total number of events. Okay, number of interested events divided by total number of events. Here you are interested in a single number, one number, whatever that number could be, randomly, out of total number of events, which is 543. And if you do 1 divided by 543, what will be the number? It would be approximately 0.001 something, right? So this is the chance that someone is going to win today's competition. So here also there is a learning for you all. Probability. Yeah. So now, sorry, let me randomly generate 2 or 3 times. Look at that. It's gonna randomly do that. Randomly, it's random. Okay. On a count of 3, I'm going to click on this, and the number which appears, they will receive a special surprise gift. Okay. It is tagged to monetary gift. Okay. Now, 3, 2, 1, go. 213. Let's see. 213, 213. Pavani. Do we have Pavani Chirasani? Pavani, you are the winner for today. Congratulations. Let me cross check once again. 213 and 213. Yep. Pavani Chirasani, you are the winner. Our team is going to contact you and give you the surprise gift. Congratulations. Okay. Now back to our discussion of the various data types. There are predominantly 2 data types, which is continuous and discrete. Continuous data means any data which can be represented in decimal format. What does that mean? That means that if you say plot weight of people, weight can be 80 kgs, or weight could be 80.2 kgs, or weight could be 80.21 kgs, or weight could be 80.213 kgs, so on and so forth. You can go to any decimal possible. For that case, people were trying to measure weight of COVID-19 virus. And what is the weight of COVID-19 virus for that case? Let us see if there is anything that is here. Okay. It's given somewhere here, but then that's okay. The weight of COVID-19 would be very, very small in decimals. 0.00000 something 1 grams in that way, or milligrams in that way, right? This virus is creating ruckus on the planet, yeah? But then you can go to any decimal level possible to represent that number. And when you represent something in decimal format, and if it is going to make sense, if it is going to make sense, it is called as continuous data. What do you mean by discrete data? If you represent something in decimal format, if it does not make sense, for example, number of mobile phones, I can say I have 1 mobile, or I can say I have 2 mobile phones, Can I say I have 1.78 phones? If I say I have 1.78 phones, you'll say, hey, you'll probably get hold of AP State Skills Development Corporation and say, hey, whom did you get to train us? He's telling 1.78 phones. Is that possible? That means, do I need to break my phone into multiple pieces? Yeah. So if you represent something in decimal format, if it does, and if it does not make sense, that data is called as discrete data. Very, very important. Okay. Why are these data types important? Because based on the data type, when we discuss about our deep learning algorithms, a lot of things change. A lot of things change just based on whether your data is discrete or continuous. I have a question for you. Let me put a poll question here. And the poll question is as follows. So the question is number of, not number of, let me say, height of a person. Is this continuous or discrete? Yep. Can you answer this, please? What is height of a person? Is it continuous or discrete? It is continuous. Wonderful, my dear friends. It is continuous. Why? Because height can be in decimals. Is your height only 5 feet and only 6 feet? Don't you see anything in between? Your height can be 5.7, 5.7.5, 5.7 point something something. And if you represent your height in centimeters, yep, it'll be in decimal format. Next question. Number of cars. Is this continuous or discrete? Yep. What do you think? Is this continuous or discrete? Discrete, you can say you have one car or you can say you have two cars. Can I say I have 1.89 cars? No, we cannot, right? If you cannot represent something in decimal format, it is discrete data. Number of cars is discrete. Okay. All right. Number of times your wife beats you. What is that? That is also discrete. Yeah. I mean, on a jovial note, you might want to ignore that. All right. Here we have continuous data. We have discrete data. Within discrete, you have categorical and count. Within categorical, you have binary and multiple. Within multiple, you have nominal and ordinal. Oh, wow. Let's discuss all these now. Very, very important because before you go to data collection, you need to understand these aspects. Binary means, does a patient have cancer or no cancer? Two. You have two classes. Binary, bi for two. Will a person default on the loan or not default on the loan? Binary. Is a credit card transaction fraud or not fraud? Binary. Two. Will an employee treat or not? Is again binary. That means, will an employee resign or not? Will a customer churn or not churn? Once again, it is binary. Will a person claim an insurance policy or not claim an insurance policy? All these are examples of categorical binary data. If you have more than two categories, you call it as multiple. For example, default or not, right? So for rather than will a person default or not default, maybe you want to classify in this way on, did the customer pay the installment, every month installment, on time or with a delay or ahead of time? Are you paying on time? Are you paying ahead of time? Or are you paying with a delay? Here you have one, two, three categories. Since you have more than two categories, it is called as multiple categorical data. There could be many things. If you get down at an airport, okay, say you got down at an airport, would you take a bus to reach the city from the airport, or would you get into a cab, or would you prefer a train, or would you prefer a carpool? Multiple categories greater than two. If you have more than two categories, it is multiple. If you have only two categories, then it is binary. Very simple, very straightforward. Next, you have count data. Count means number of people resigning from the job. Number of cars which cross a traffic signal. If you have a traffic signal, how many cars are crossing this traffic signal? Okay, from probably 9 a.m. to 10:30 a.m. daily, how many cars cross a traffic signal? Number of cars is count data. Number of flights which are taking off from 7 to 9 a.m. Number of passengers who are crossing the security inspection from 6 p.m. to 9 p.m. All these are examples of count data. Okay, all these are examples of count data. There is again another difference here called as nominal data and ordinal data. What do you mean by nominal and ordinal data? Nominal data means they're just names. For example, which soft drink do you like the most? Right? Which soft drink do you like the most? Do you like Kingfisher? Soft drink, okay. Kingfisher also has soft drinks, by the way. Or Coke or Budweiser. Okay. Which soft drink do you like the most? There is no natural sequence associated with this, right? Thumbs up. There is no natural sequence associated with this. If there is no natural sequence associated with this, it is called as nominal data. But then there is a running race going on. Who will come first? Who will come second? And who will come third? There is a natural sequence to this. Will a customer be satisfied? Will you all be satisfied with this training? Or will you all be neutral about this training? Or will you all be unsatisfied? There is a natural sequence to this. Order. There is an order. Whenever you have an order to the data, it is called as ordinal data. Whenever there is no order, it is called as nominal data. Okay, and there is also something called as interval data and ratio data. This is the last, okay? Trust me. These are the various data types that you should be aware of. Now let's take an example. On one, a few years back, okay, a few years back, me and my friend, we were traveling from New Jersey to Jeddah, Saudi Arabia. Okay, so we both obviously it was on a consulting engagement for a client called Saudi Aramco, which is one of the giants in Saudi Arabia when it comes to oil and gas. It was an analytics project only. So when we booked the flight and when we checked into the airport, we were supposed to take a boarding pass. They have given us a boarding pass. In that boarding pass, it was written that we need to board flight number AK-67. I'm just giving some number. This is a Malaysian aircraft, right? 371A. In that way, you'll have various flight numbers. We were asked to board flight number, I think 371A. AK is more to do with Malaysian Airlines, sorry, AirAsia. Okay, here. And then on the boarding pass, there was something else which was written. And that told that we need to board at gate number 21. Then when we started our journey, pilot has told that outside temperature is, they told in Fahrenheit, but then 16 degrees Celsius. Okay. And when we were landing in Jeddah in Saudi Arabia, pilot told that outside temperature is 32 degrees Celsius. And then my friend told me that, do you know what, Barani? Outside temperature is twice as that of what it is here, what it was in back in New Jersey. I told no. I immediately told no, my dear friend. 32 degrees Celsius is not twice of 16 degrees Celsius. He was like, hey, what kind of a data scientist are you? You cannot even do proper mathematics. I'm saying outside temperature is twice as hot as what it was in New Jersey. I told him, no, it's not twice as hot. Then we argued, and I could finally convince him that outside temperature is not twice as hot as temperature in New York. I'll tell you why and all that later. And then when we boarded there, in fact, this happened in New Jersey itself. My friend purchased Wall Street Journal for $1, and I purchased Economist for $2. Then my friend told, do you know what? You spend exactly twice as what I've spent. Then I told yes. My friend was like, oh my God, are you mad? Are you nuts that here you are agreeing with me and here you're not agreeing with me? What's wrong with you? Then I told, okay, let me explain. And then the explanation started. Now let us understand the explanation bit. Okay, here. Flight number. Is it nominal data or ordinal data or interval or ratio? It is nominal data. Why is it nominal data? This is nominal data because flight numbers can be anything. It can be 371A or it could be 371B or it could be 369Z or it could be AK-67, AK-97. It could be any number, absolutely. You cannot put them in a sequence. For that case, the same flight which flies from one point to another will have a different number. If it again flies back from the destination to the origin, it will have a different flight number. So it's nominal. There is no order. There is no natural sequence to it. Hence, it is called as nominal data. Gate number, how will gate numbers be? 0, 1, of course there won't be any gate number 0 I'm sensing, but then you'll have gate number 1, 2, 3, 4, 5 in that way. So these gate numbers have an order, a sequence. When you have a sequence, it is called as ordinal data. Okay, when you have a natural sequence, it is called as ordinal data. And then we have temperature. This is interesting. And when you have order, it is called as ordinal data. So I'll write it down here that this is nominal data and this is ordinal data. Why did I say no? Let us understand. I gave this explanation to my friend who also happens to be a data scientist. Uh, why did he not know? I'm making up a story here. Okay. So, okay. So you get a person from Antarctica. Mr. A is from Antarctica. Okay. And get Mr. SA from Saudi Arabia. Antarctica always minus degree Celsius. Saudi Arabia, oh my God, it's too hot. Right? Of course, it gets too cold also, but then it's too hot as well. If I expose them to 16 degrees Celsius, and if I ask this guy, what do you think about 16 degrees Celsius? The guy from Antarctica might say, oh my God, it's very hot. Why? Because they're always exposed to minus degree Celsius. And Mr. Saudi Arabia might say that, oh my God, it's very cold out there. Because they are exposed to, even 45, 48, 50 degrees Celsius. It's too hot. The same number, I'm not changing it. 16 degrees Celsius is 16 degrees Celsius. But then different people have different perspectives about that, different perceptions, different perspectives. If you have a number and two different people have different understanding about that, then it is called as, you know, uh, interval data. Just a name called as interval. Okay. And finally, $1 or $2. Give $1 to this person or this person, they can buy the same thing. $1 is $1. No one will say $1 is more or high. It's like if you give me a 100 rupee note, yeah, you can buy probably whatever you get for 100 rupees. I can also buy the same thing for 100 rupees. There is no difference. Those numbers or those variables which have a universal definition and it does not vary based on the perceptions of the people, that kind of data is called as ratio data. Okay, that kind of data is called as ratio data. Now tell me one thing, or let me explain this. If you want to collect the data and work on the data, your first preference should be given to which data type? Ratio data. Why? Because you can perform all the statistical analysis. You can perform all statistical analysis on the data if you have ratio data. The next best would be interval. The next best would be ordinal. And the last preferred would be your nominal data. Okay. So in today's quiz, you will have these kind of questions and you should be aware of this. Okay. So I'll ask you guys a question. Um, Let me ask rather a slightly tricky question. Let's see how many of y'all will get it right. Okay, ranks in army. Is it nominal data or ordinal data? Yep. What's the answer? You'll have all the various ranks, right? In the armed forces, you become a soldier, then you become a captain, then you become a general, major general, so on and so forth, right? So it has a natural sequence, an order associated with it. When you have an order associated with your data, it is called as ordinal data. Okay, it's called as ordinal data. Friends, we have our team on this, and they will be responding to your queries. Okay, now let me ask another question. IQ level of a person. Is this interval data or ratio data? Let us see. Yep. What is the answer? IQ level of a person. IQ level is interval data. Why? You might say, hey, Bharani has an IQ on a scale of 1 to 10, and IQ level is 6. Someone else might say, no, I disagree, it's 5. So it depends on the perspective, perceptions. Okay, someone who is more intelligent than me, who has better IQ than me, might say, no, he has an IQ level of only 2 on a scale of 10. Someone who doesn't know as much as I know, someone whose IQ level is lower, might give me a higher IQ level. So it is subjective. Okay, that's very, very important thing that you need to remember. Okay, then, all right. So here, so within continuous, you have interval and ratio. Within categorical, you have binary, multiple, nominal, and ordinal. Let's not spend too much of time. You can always watch this recorded video and get back to us after your questions. I understand a few of y'all might be listening to these terms for the very first time. At word go, you might not understand everything. Hence, we are giving you access to our YouTube channel, and then you can watch that. Let me click on this and also show you that quickly. So these are the two videos that we have, and every day video will be uploaded in this every day, and you'll have lifetime access. But the only thing is, you please subscribe, otherwise you will miss out on the future videos which get updated or uploaded here. Okay, please subscribe. Do not forget that. Okay. Let me quickly do this. Okay, I'll take a quick 1 minute, 1 minute only off. I go to 360DigiTMG and I click on this YouTube link, and I do not think a lot of y'all have subscribed, so I'm going to post it here. Yeah. Please, can you all click on this and subscribe? I'll give you a quick 1 minute to do that. Everyone, please, I'll be looking at the count here on whether it is increasing or not. Please, can you all do that? Yeah, a few of you all have started doing that. Can you all please proceed further? Let me look at the count once again. I'm posting on the chat window. We'll do that. We'll do that one by one, Ganesh. Let's stick to this, please. Yeah, can you all please do that? I'm seeing that the count is increasing at a snail pace. If you are faster, we can proceed further quickly. I'll refresh it again. We will take not more than half a minute now. I posted that on. No, no, you just need to log in, and you need to log in with your account and then just click on subscribe. Wonderful. We will ensure that it reaches 7.9. Come on, let us take it up as a challenge, friends. Can you do that? If you have already subscribed, then you might want to ignore. I'm posting that link. If you have subscribed, you might want to ignore. People who didn't subscribe, quickly please, so that all the future videos. Oh yeah, we are getting there. It's just a slight push and we will reach 7.9. Come on. If you have already subscribed, yeah, you might ignore. If you haven't subscribed, please subscribe. That's the link. Once again, I posted. Let's see. Wow, we are just an inch away. We are just an inch away from reaching 7.9. Come on, let's see. Are you subscribed with all the four? Wonderful. If you have subscribed, that's good. If you haven't, then please do that. I posted once again, and then let me refresh it now. Great. Congratulations. Congratulations. You have made it. Thank you. Okay. Do you know what? If you subscribe to our the other social media forums, another advantage is we keep posting a lot of such articles. If you're still confused on, hey, do you know what? I need more examples on interval ratio. We will do that. Okay, on the groups we'll be posting. Now, if I were to look at continuous data, categorical and count data, out of these three, which of these three is qualitative and which of these three is quantitative? Can you tell me? Which of these three? I mean, if I were to select continuous, categorical, and count, which of these three is qualitative and which of these three is quantitative? Yep. So what do you mean by that? Qualitative means if I say, how was the training? If you say training was good, then it's qualitative. If I say on a scale of 1 to 5, 5 is the highest and 1 is the lowest rating. On a scale of 1 to 5, can you tell me how good the training is? If you say 5, then I can actually gauge on how much you like. If you just say good, bad, it doesn't really echo anything else, any interesting insight. This keep happening, with respect to the employees, especially at our office space. Also, it's no different. When I ask people on, hey, why are you guys late? People say that, you know what, we stay very far away from office. And then I ask them to this is, if you say your home is very far from office, you're being qualitative. If I ask them how far is that in kilometers, then they might say, do you know what, it is 900 meters away. Right? Then the moment you quantify, I know on how far it is. Right? So always when you have quantitative, that is numbers, it will give you more interesting insight. For example, if people do a survey on whether you're happy or unhappy about your married life, right, you will all say happy. Right? Lockdown, you're staying along at your home with your spouses, so you'll obviously say you're happy because they will also be listening to you, right? So you'll say happy. But then if they say on a scale of 1 to 5, 1 being least happy, 5 being very happy, give a rating, then what would you rate? Majority of them, what would you rate? 1, right? So quite contradictory, but then things changed really. On a serious note, things change when you take qualitative feedback versus quantitative feedback. So continuous data is all about numbers. Count data is also about numbers. When you have numbers, it is called as quantitative. It's quantitative, right? And if you have categorical data, it is qualitative. If you say how much time will this training last, if I say it will last for a lot of time, that is qualitative. If I say training will be there for 3 hours, then it is quantitative. Okay, and we've already discussed about structured and unstructured data, so I'll poll a quiz question here at this point of time on what data type is this. Let me see who will answer. If I were to ask this on speech data, is this going to be structured or unstructured data? What will your answer be? There we go. Is speech data wonderful? Speech is unstructured, no doubt about that. Yes, well said. Speech data, you cannot put it on a table. You cannot put it on Excel sheet, for example, or a spreadsheet. So it is structured. Sorry, unstructured data. Speech is unstructured data. Very good. Another question is, what about Facebook comments? Is this structured or unstructured data? Let me see how many of y'all will get it right. There we go. Unstructured. Sorry about my spelling mistake there. Yeah, it's unstructured. Absolutely right. Facebook comments is unstructured because it has text, right? Some comment, you type something. It's unstructured. There's no proper structure to it. Okay, wonderful. So now, another question is, can I convert unstructured data to structured data? Yes or a no? Can I convert structured data to unstructured data? Yes, you can. Wonderful. I'm really happy, so happy that you're giving me, majority of y'all are giving me the right answer, right? Y'all are right. Okay. The next is big data versus non-big data. People often have this doubt here, confusion on what is big data actually. See, I can give you one thing, bookish example, which obviously is again academia based. It's not at all industry relevant. I'll give you very simple example because if you ask me for books, I can give you a lot of pointers, but how will that help you is a point that you have to think, right? So if I say that if you have these 4 V's or 3 V's, it is called as big data. That's what textbook example would be. A few books say 5 V's, 6 V's, etc. For example, high velocity data coming at a rapid speed, huge volume of data, and variety of data means images, videos, speech. And if you have a lot of veracity in the data, veracity means you cannot rely on the data. If you have all these characteristics in your data, it would be called as big data. Wow, wonderful explanation, bookish example. But then, practically, do you know what? Zettabytes of data, exabytes of data is not big data, friends. Or let me put this, Pratt and Whitney, uh, 844 terabytes of data. So what happens here is a twin engine aircraft on a 12-hour flight can produce 844 terabytes of data. And how much hard disk space do you have? When you look at your hard disk, you'll have 1 terabyte or maximum of 2 terabytes. Even if you bring in big servers, how much space will they have? And here I'm speaking about one flight, that too in 12 hours journey, would generate how much data? 844 terabytes of data. Can you store this on your computers? No. If you cannot store your data on the given hardware that you have, that means you just ran into big data problem. Question to you. If I have a 1 terabyte hard disk, it could be a solid state drive or hard disk it. And if I have 1.5 terabytes of data, is this 1.5 terabytes of data, will this be called as big data? Yes or a no? Practical question, no textbook example. Practically, if I were to ask, I have 1 terabyte hard disk, but you give me 1.5 terabyte data. Would that be called as big data for me? Answer is a super duper yes. I cannot store it. So it's big data. It is as simple as that, friends. Okay. So it is contextual. It is contextual. Given the limitations that I have, can I handle the data? Not just from storage perspective. That means can I store that or not? Another dimension to this is from processing perspective. I'm sure you all use Excel, Microsoft Excel. Or let me ask this question because I want to make an interesting statement here. So I think it warrants that I ask this question to you guys on did you work on Excel? Microsoft Excel, yes or a no? Yep. Can you take a poll here? You have. Majority of them have worked on Excel sheets. I'm sensing that 6% no would be only students. So my obvious question would be, did you ever try to open a 500 MB Excel file? Just a 500 MB Excel file. If you haven't done so, go to internet, download an Excel sheet which is of 500 MB and try to open that on your computer. Do you know what? Your computer will cry and you'll keep getting this symbol. Going on, operation is going on. You go for lunch and come back, still it will be going on. Okay, you go for a snacks break and come back, still it will be going on. You go home and the next day come back, it will be going on. That means you just ran into big data problem. Even if it opens, there is something called as pivot table. Try to do a pivot table on that Excel. Your system will again start crying. Okay, so that's big data versus non-big data. It is very contextual, my dear friends. Okay, then this thing, and then we will take a break, or I want to be a little religious in terms of taking breaks. Okay, it's almost 11:29 now, so we'll take two breaks of 10 minutes each. That's what a few of you all have requested. So it's 11:30 now. Let us be back by 11:40 and let us take a break until then. And when we come back at 11:40, we will discuss about cross-sectional data, time series, etc. balanced, imbalanced, and real-time processing. And then we will get into data cleansing. Please take a break and please be back at 11:40. Hello everyone. I'm sure you all are back from the break. Uh, sure, Bharti. I'm so happy. Yeah, I'm unable to fill that in a sudden network. No, no problem. We will consider Bhaskar. Yeah, we will also look from the back end and then see on whether you were active or not. Okay, let us continue with the session and understand about cross-sectional time series and longitudinal or panel data. Cross-sectional data means if you have a data like this, wherein say you have your output variable that you want to predict and the various input variables. And say you have data of 10,000 patients. And patient 1 has COVID-19 positive. So I'll put it as, because COVID-19 is going on, I felt that's a good example. Okay, nothing else. So positive. Second patient is tested COVID-19 negative, third negative, fourth negative, fifth positive. In that way, you have the data. Here in this data, do you think date and time make sense? That means, does it work this way that if you go for a medical test on Monday at 11 a.m., no matter what, you'll be tested positive. Okay, why? Because Rahu Kalam. So you have COVID-19 positive. Will it work that way? If you go on Tuesday at 3 p.m., then you'll be tested COVID-19 negative. Does it work that way? Absolutely no. So the date and time when you go to get your medical test done doesn't matter whether it is Rahu Kal or Brahma Kal or some other Kal, until and unless you're superstitious. So the moment you say that date and time is immaterial, that means you need not even store the data here in the sequence in which the patients come to your hospital. Sequence is unimportant. If sequence is unimportant, the date and time when you have undergone the test, the date and time when this row is recorded, if it doesn't matter, the underlying data is called as cross-sectional data. And usually in your cross-sectional data, you'll have multiple variables. You'll have multiple variables. Then what is time series data? Time series data is that data in which the data is arranged in a sequence. If you have number of COVID-19 cases in India, what will happen to the number of COVID-19 cases? If someone says, hey, can you forecast the number of COVID-19 cases which we might see in India for the next 1 week, then, or for the next day, then you certainly need the data, uh, today's data, yesterday, 2 days back, 3 days back, 4 days back, 5 days back. You need the data in that sequence. That means the date, like probably this is 11th June data, 11th Jan, how many cases did we have? 12th Jan, how many cases did we have? So the date and time is very important. Date and time and the sequence in which you arrange the data is important. If the date and time and the sequence in which you arrange the data is important, Then this data is called as time series data. And in time series data, you will have a single variable. If it's number of COVID-19 cases, that's it. You'll have a single variable. And the data here would be arranged based on date and time in ascending order or descending, right? It will be ordered based on date and time. If date and time and sequence become important, the underlying data is time series data. Say you want to forecast on what will be the sales of your organization for next month. What will be the profits of your organization for next month? What will be the temperature? Number of COVID-19 cases, the way the number of vehicles is increasing, all those things. You have to handle using time series analysis. Then you have longitudinal data or panel data, both mean the same. Okay, longitudinal data or panel data. What happens in this longitudinal or panel data is that it is combination of cross-sectional data and time series data. Okay, it is combination of cross-sectional data and time series data. So here you will consider number of COVID-19 cases in India, number of COVID-19 cases in US, number of COVID-19 cases in Malaysia, in UK. Hey, why am I giving these countries examples? Because we have our employees, 360DigiTMG employees working in all these countries. So I've taken that example just like that. Yeah. Now, if you have multiple variables, you are bringing in a feature of cross-sectional data. And if you have this data sorted in a sequence, 12th Jan, 13th Jan, 14th Jan, so on and so forth, based on date and time, if you sort the data, it is time series. So I'm bringing in the capabilities of both cross-sectional and time series into this data set, and this is called as longitudinal or panel data. Look at this, trust me friends when I say this, and professors, 99.9% of the people who deliver training, they jump directly into this data types and then they will explain you the concepts. If you don't know what are the various data types, what will you capture? If you don't understand the business problem, what would you do with that data, right? So hence we are going in a very, very structured manner. We have no scope, no room for unstructured training here, right? So that's why we are discussing about project management methodology. And that's why, we will get to the concepts. By the time we get to the concepts, all these should be very clear. Okay. So if you have multiple variables, you are bringing in cross-sectional aspect. If you sort them in a sequence, you're bringing in time series aspect. If you have both of that, it's called as longitudinal or panel data. Then you have balanced data versus imbalanced data or rare events. Let me explain this. If I give you a data set of, say, cancer prediction, that's, say, your output. Does a patient have cancer or no cancer or no cancer, no cancer, cancer? In that we have the data of, say, 10,000 patients. And say you have the inputs such as age, gender, historical medical conditions, so on and so forth. What data is this? Is this cross-sectional or time series? That is what I want to ask you as part of the poll question. Is cancer data set, okay, or let me say, what is cancer? What type of data is cancer data set? Is it cross-sectional or time series? Yep, please can you answer this? Wonderful, it is cross-sectional. Hats off. I'm sure you all are very active. It is 100% cross-sectional data, because again, the date and time when you go and get your tests done is not important. Why do you need date and time to predict cancer? Right? It is not numerology to predict cancer, right? It's science. Okay. So it is cross-sectional data. Here, if you look at this output variable, only the output variable, okay, not the inputs. You do not look at the inputs. You look at only the outputs. If this output variable has cancer and no cancer, and if you have say 50% of these rows as cancer, that is 5,000. And if you have another 50% as no cancer, that is another 5,000. Do you think it is balanced or imbalanced? This is balanced. 50%, 50%. This is called as balanced data set. And to call a specific data set as imbalanced data set, okay, to call a specific data set as imbalanced data set, there is a thumb rule. Thumb rule. When I say thumb rule, take it with a pinch of salt. Okay. So that thumb rule is that if you have one of these classes to be less than 30%, then you call this as imbalanced data set. Okay. If one of the classes or categories, both mean the same. If one of these classes or categories is less than 30%, you call it as imbalanced data set. Say you have 30% cancer and 70% non-cancerous. Cancer and no cancer. Then this data set is called as imbalanced. If you have 40% and 60%, it is still balanced. Why? Because you didn't meet this rule. If it is 35% and 65%, still it is balanced. Okay. Only if one of these classes, either cancer or no cancer, if one of these classes has less than 30% entries or rows, then it is called as imbalanced data set. Otherwise, it is balanced data set. Okay, now next. You know about balanced and imbalanced also. What is the next thing? Batch processing and real-time processing. Okay, once again, my dear friends, when it comes to balanced, it is simple random sampling. When you have imbalanced data sets, you have random resampling, bootstrapping, k-fold, repeated, stratified, leave one out, smooth, modified smooth. There are a bunch of techniques, my dear friends. Okay, but then we will be confining our discussion only to balanced, imbalanced. Then we will discuss about k-fold cross-validation any which ways. So we have batch processing and real-time processing. What is the difference between these two is what we need to understand. The difference between these two is that when you have a specific data set, here. Okay, and which example should I take? Okay, let me take loan defaulters. Everyone, you know, is convenient with that, right? So say you have a database. Within database, what will you have? You'll have data. Okay, you'll have data. You'll have data of, say, customers who have applied for loan. So I'll take here customers who applied for loan. The moment a customer applies for a loan, there'll be a loan application form. They fill that, and then that gets uploaded onto the database. Okay. Say you have a loan officer. This loan officer should approve or reject the loan, right? After the loan is applied, you have to approve the loan or reject the loan. And here, say the moment people apply for the entire day from 9 a.m. to 5 p.m., all these things which are uploaded, your IT department pulls the data daily at 7 p.m. and then they process it through Python. And you run it through your machine learning algorithm. Here you'll have a machine learning algorithm which predicts on, which gives you a probability on what is a probability that a person will default or not default. Then what happens? The moment you say that, okay, there is 83% probability or chance that someone might default on the loan, then what you do is you take this result and you write this result back to your database against customer A. If this guy is customer A, you write here saying that there is 83% probability that a person will default. Then the next loan application is processed through this. Say it predicts that there is, I mean, if it's 83% probability that someone will default, then someone will not default would be 17% for this guy. Say for the other guy, it says there is 50% probability that a person will default. You go back, write the results in this way. And these results, write back results to the database. Once the results are written back to the database, you take those results and then display those results to this loan officer on a dashboard. Okay, so you'll have a dashboard. It could be a dashboard or it could be a Tableau data visualization tool, doesn't matter. So here the results will appear as, hey, this customer 1, there is 83% probability that a person will default. Customer 2, there is 50% probability that a person will default. Customer 3, 10% probability. So the loan officer the next day will look at these. She might say approve. Further processing needed, further investigation, reject the loan. In that way, they take a call. What is happening here, the point that you need to understand and remember is that daily at 7 p.m., we are taking batch of all the loan applications. We are taking the batch of all the loan applications and we are processing it to get the predictions. Okay, you're taking all those and a batch is processed. Batch of applications gets processed at daily 7 p.m. This is called as batch processing. Okay, then what is real-time processing? Let me give you another example. Okay, say it's a dashboard. Based on the dashboard, your loan officer takes a decision. Now, let us understand about yet another similar kind of example. Again, I'll take the banking example. Okay. Say you have a database of all the credit card transactions. Okay, so you have customers who use credit card. Okay, here, as in how customers use credit card, data gets stored on the database. What kind of data? Which card did the customer use? How much money? What is that person purchasing? Where is this person purchasing? All that. And here you cannot say that I will do a batch processing once in a day. No. Here you need lightning speed, fast responses. Just like that. The moment you do a transaction, immediately you need to take that transaction, process it through your statistical tool, and immediately classify on whether this is a fraud transaction or not fraud. And you'll have probabilities. It might say, hey, there is 91% probability that this is a fraud transaction. You take that result back and then quickly write it back to your database. Once you write the result back to your database, immediately display that on the dashboard of your fraud analytics team, fraud analyst or fraud analytics team. Here, the fraud analyst who is going to monitor this dashboard will keep an eye on this. And the moment it says 91% probability, it will start blinking. Yeah, this will start blinking that 90% probability that the person will default. 90%. The fraud analytics team person would immediately call this customer. So even more better automation is these people will all be wearing headsets to take the calls. Call will automatically go to the customer. Call will automatically get routed, and this fraud analyst will ask the customer on, dear customer, did you do this transaction? If the customer says yes, then you approve. If your customer says no, I haven't done that, then you reject. This is called as real-time processing. Okay, this is called as real-time processing. You need to understand the differences, because when you define your architecture, and okay, one more thing that people are uh, not focusing upon is defining data pipeline and defining architecture. And when we provide any internship opportunities to our students, because people from Indian School of Business, people from BITS Pilani, they keep doing internship with us. And when they do internship projects, they learn all these things from us. It's not a typical internship wherein we give you a certificate for you as a student and you go submit. No, it comes when you put in effort, right? How do you real time establish the APIs? How do you connect the various disparate systems? How do you do the prediction and write back the results? If there is a new entry in your database, can it automatically detect and automatically predict and write back the results, which will automatically appear on the dashboard seamlessly without human in the loop? This is what industry wants. This is what people want in the companies. And if you are churning out people who only knows algorithm, then let me also warn, you can just make a record of this. You can sue me if this doesn't become true. Auto ML, right? Amazon SageMaker, Microsoft Azure, Google Cloud Platform, IBM Watson, they are doing amazing things. You need not know even a single line of program. Still, you can do the job. That is what they are working on. If we are not very far away, it would take probably another 1 year max. And by the time your first year BTech students get into second year, your curriculum might become obsolete. That's the pace at which developments are going on. Okay, anyways. So once you understand about all these various data types, you come here and do the data collection. Because now you understand what kind of data is needed, how much amount of data would be needed, is it real-time processing or batch processing? You get to know about all these things, right? Based on this knowledge, you proceed further with the data collection. And even when it comes to data collection, don't go to primary first, look into secondary. If you have data in secondary, then do make use of that data. If you don't have, only then go get into primary data. And once you have the data, you proceed to the next step, which is data cleansing or data preparation, which is also called as exploratory data analysis, feature engineering. All these things are a few things which overlap with each other. Okay, they all overlap. So you cannot delineate one from another by drawing a boundary. Okay, and when it comes to data cleansing, there are a bunch of these techniques which usually we cover as part of our typical advanced data science training. Yeah, it's not covered in this AI because we expect people to already have little understanding about uh, data related activities. Yeah, but then we're not restricting it. We already have given all those things in the mind map. Please read it. Okay, next. Exploratory data analysis. You have a bunch of these: first moment, second moment, third moment, skewness, right? Kurtosis. In kurtosis, you have mesokurtic, platykurtic, leptokurtic. What does each mean, right? As I don't know. I mean, now this is wealth, guys. This is wealth. And then you have graphical representation, wherein you have univariate plots, bivariate plots, multivariate plots, right? Density plots and all that. And if you have access to this mind map, it will be a very smooth sail. And I'm writing a book, and I don't know, I'm hoping to launch that book by 15th August, at least the digital version of it, by including all the 50 plus projects that I've worked upon and the consulting experience that I have for the last 15 years. I will launch it. I'll keep you guys you know, informed on that. Then we have data mining and machine learning. But before we go there, let me throw some light on feature engineering. Okay, you will understand better. Because when it comes to images or when it comes to your time series data, there are a few things that you need to certainly understand. Of course, not everything, but certainly a lot of things which are needed for you. Okay. So one thing that you need to remember is that if your customer gives you data for your analysis, obviously, right? if you want to analyze, say there is a financial services insurance client or customer who has some business problem. He hires you because you are data scientist or AI expert. So data is given to you and you're asked to build the model. A person who has only bookish knowledge, do you know what they will do? If I give them, say, output variable and 1, 2, 3, 4, 5 input variables, they'll just take the data as is and immediately they'll start building a model. Bookish person will not get a job in the entire lifetime. He or she will not get a job. Bookish, because this data is your first enemy that you need to attack. The raw data is the worst data ever. Until and unless you transform the data, it is not going to help you. Until and unless you perform feature engineering on your data, it will be meaningless for you. For example, let me take a bank example only. Okay, since I work with HSBC, I will rate it very high. Just because I work, right, I need to speak good about that. And then say you have a State Bank of India. They have been one of our customers. So I'll give them a slight preference. And we have, say, Standard Chartered. 3 banks. All these 3 banks are given data. What data? Say all these 3 banks are given data on output variable. Say credit score is given. Then you have your debt. Some credit score, you know, CIBIL score, right? Credit score is same thing. You can attain maximum of 900 points, 0 to 900. If you're repaying the interest amount of loan amount on time, you'll get a high score. Okay, that aside, that aside, if I say that there are two people, person A and person B. Person A has a monthly commitment of 10,000 rupees. Every month he has to pay 10,000 to a bank. Okay, and this person B every month has to pay 1 lakh rupees to the bank loan. Every month person A has to pay 10,000 rupees to the bank. Every month person B has to pay 1 lakh rupees to the bank, or 100,000. Which of these customers will have a good CIBIL score? Which of these two customers would you be willing to lend loan? If you have to lend loan to A versus B, whom would you lend loan? That person who has already a commitment of 10,000 rupees per month, or to that person who already has a commitment of 100,000 rupees or 1 lakh rupees per month? Answer this, please. Let me take a poll question. And on whom will you lend loan to? Person A or to person B? Yep. Please, can you answer? That person who already has 100,000 or 1 lakh rupees monthly commitment, or to that person who has 10,000 rupees monthly commitment? I need not even look at your responses because the answer is none of that. None of that. Twist in the tail. Why? Because you also need to look at their income alongside their debt. If person A has an income of only 12,000 rupees per month, and if this person is already paying 10,000 as loan, so this person will be left out with only 2,000. Person B who has 100,000 rupees commitment, but probably this person draws 1 crore rupees per month as salary. Then this person still has 90 lakhs amount to be spent. So banks will be happy to lend money because this guy has the propensity to repay the loan. But this guy has only 2,000. Chance of repaying is a very bleak. If I give this data and if a specific bank is going to use this data as is, if this is your output and these are your inputs, you just don't worry about these equations now, okay? I'll explain about these equations later. This is how it will be. You use both of these inputs and build a model. Wonderful. Say accuracy is 90%. So Standard Chartered Bank has built a model using the data and they have achieved 90% accuracy. But they won't be very successful. Why? Because the data scientists who are working here are bookish data scientists. Bookish data scientists, if they are going to use this data as is to build a model. People who are interviewing are becoming intelligent day by day. Okay, you cannot fool the interviewers. Neither can you fool your customers because they are also becoming intelligent. So the only way out is we should upskill ourselves in a better way. So State Bank of India, say the data scientists are slightly knowledgeable people. They're not these bookish students who got a job. These are intelligent students who got trained by a better person or experienced person as you. Or you all professors, because now you are learning the practical artificial intelligence training, not the theoretical. Okay. I mean, don't assume that just writing a program is practical. No, no. Don't get into that mistake, please. Okay. Understanding how to solve a business problem by implementing an apt solution is what is needed. So State Bank of India, what they might do is, they might say, do you know what? Instead of using two variables inputs, can I not use debt over income? Can we not use this? If I can use debt over income and predict the credit score, then you'll have an output variable and one input variable. That's it, and build a model. So y is equal to p plus w1x. And this time maybe you might get a higher accuracy. Even if you get 90%, then this will be more preferred than this. Why? Because of something called as principle of parsimony or Occam's razor. Principle of parsimony or Occam's razor says that simplest of the models are the best models. Simplest of models are the best models. Okay, please remember this, that simplest of the models are the best models. And finally, you have the best. My first company that I worked with, HSBC, 2005. Okay, so people in HSBC say are very brilliant because I work there. That's fine. No? I'm trying to boast. Yeah. So what HSBC does is usually they hire people who have economics background. Why? Because if you look at debt or if you look at income, and when you do a simple plot, when you take your income, for instance, and when you do this plot, majority of the people whom you see will have low income. Say you're plotting income here, sorry, and population here. Income and population. Majority of the people have very low income, and only a small section of people have high income. Only the small portion of people have very high income, and majority of the people have low and medium income or middle income. They fall under middle income group. This is law of economics. Same is the case with debt also. Income or debt follow exponential distribution, and when something follows exponential distribution, to capture the relationship, what people do is they take log of debt divided by log of income. So if you take a log transformation, it will capture this relationship, which is called as exponential relationship. And then how do they build? They just take this as the input, and the output would be your credit score, and they build a model. Same, you'll have the single input, but then accuracy will usually be higher. Even if it is the same, HSBC will be taking very good decisions based on should we approve the loan or not. Making sense? Now, if I'm going to interview a person who has used the data as is and built a model, I would certainly have a very bad impression about this person. On this person who has actually done some transformation of taking debt over income as opposed to these two, I'll have slightly better impression. And this student who has done log of this, wow, I don't mind paying him additional salary. But he is the one person whom I'm going to pick instantly. And this is how we need to train our students. If the students become this, you need not worry about placements. They will automatically get placements. They will automatically get jobs. We need not struggle, run our companies. They will come running to us, right? So this is what I firmly believe in. Okay. Hence, again, to tell you all, this is practical AI and deep learning training. I'm not going to teach only theoretical concepts, which you can anyways get on YouTube or LinkedIn or or Google. You'll get a lot of books, read them, but ultimately you'll have only bookish knowledge. All right. Now I shall. Okay. I have a lot of examples here to quote, but fine. Let's move on now. Then we need to move into data mining or machine learning, which includes supervised learning, unsupervised learning. Supervised learning means predictive modeling, wherein you build prediction models. There are a lot of prediction models which are available. One such thing is your neural network, which is called as black box technique. In neural network, even if you spend 1 year, 2 years, 3 years reading or attending the sessions, we will not be able to cover everything, right? So we will get into perceptron algorithm, multi-layered perceptron. We will deal with images, recurrent neural network, long short-term memory, GRUs. Until here, we will follow a methodology of theory plus practicals. From thereafter, because of In the interest of time, we will touch upon each and every architecture, but trust me when I say this, that these are very advanced algorithms, and there are a bunch of other things which are listed down here. Then supervised learning means in the underlying data set, you will have the output variable and input variables. So here, the only thing is the output variable is known. When it comes to unsupervised learning, this output variable is unknown. Okay, meaning you'll not have this variable, you'll have all the other variables like segmentation or clustering. If I can combine these two, it is called as semi-supervised. Well, there are multiple things to explain here. One thing is you take your underlying data, whatever customer has given you, create clusters or segments. Yesterday we discussed this, right? Create clusters or segments, and on each segment that you get, segment 1 or segment 2 or segment 3, you take these segments and on each of these segments apply a predictive model. You apply a different predictive model on this, you apply a different predictive model on this, and you apply a different predictive model on this. Okay, that's what you do. That means you're first applying clustering or segmentation, which is unsupervised learning, to get different segments, and then you apply supervised learning on each of these segments. If you combine these two, it is called as semi-supervised learning. And there is also another thing called as reinforcement learning. Reinforcement learning is all about making use of your algorithm in building some kind of AI driven games. Number one. Number two, reinforcement learning is also used in building driverless cars, etc. This is a different technique altogether, friends. This is a different technique, a different field altogether. Here, what happens is you will not teach your model anything. All you will say is, if it is game, you will say output is the points. You'll say just keep maximizing the points, or in a few games like chess, the minimum the points you win. So you'll say minimize the points, that's it. And it will automatically start working. And this reinforcement learning has actually done wonders in terms of AI defeats Lee Sedol. There is a game called as AlphaGo, right? It's like chess only, it's slightly different. And Lee Sedol, who is a world champion, has been defeated by AlphaGo. Okay, and not just that. What is the game called as chess game? AI defeats chess game. Forgetting the name. Google has acquired a company called as DeepMind, which is actually Swordfish. Yeah, Swordfish. Sorry, Stockfish. Stockfish is a computer chess game, which is among all the computer chess games, this is the best. It took just 4 hours for your AI algorithm to learn how to play chess, and it defeated the world's best computer game. I mean, humans cannot win against this computer chess game, and then AI has defeated that. Wow, right? So that's the power of AI. Within 4 hours, all you need to give is you just tell to your algorithm that this is the input, this is sorry, this is the output. You just need to maximize, and it will learn automatically. That is called as reinforcement learning. Driverless cars, you cannot train your driverless car on every small thing, that there is a speed breaker, slow down, there are people at 100 feet distance, so go slowly. You cannot train it on everything, right? You want your vehicle to learn automatically a lot of things. That is reinforcement learning, a big field of study. And I'm sure by the time your students BTech in AI, by the time they reach maybe complete 1 year, it will all be deep learning, deep learning. People, I'm pretty sure not many people will be using the other techniques, typical data science techniques. It will be all deep learning. Okay, so once you build your model, you evaluate your model. Okay, and that's machine learning primer. We will spend significant time on machine learning primer. Today I'm thinking that there won't be any Python stuff. We will just complete this and get a very, very good handle, so that from Monday onwards we get started with the programming aspects also. But then, as I've told you, every hour we will take a break for 10 minutes. It's 12:30 now, or 12:32. That's fine. Let us be back by 12:40, and we will take this discussion further. Break time, my dear friends. Come back fresh, so that we learn about machine learning primer, which is very, very important, and you all will love it, I'm sure. Thank you. Hello and welcome back. So let us process further. Yeah, because people, if it's too much of theory, they get they get into sleep mode. And this is exactly how it used to work in Indian School of Business ISB, wherein after every 1 hour they quickly give 10 minutes break so that you come back afresh and you do wonders. Okay, so now let's discuss about machine learning primer. Very important, and you will love it, I'm sure. So let us understand this machine learning primer. Primer means basics. Okay. When you want to get started on any project, data related project, you need first of all data. And what data do you need? Historical data. Say you have historical data. And in the historical data, what will you have? You will have your output variable and input variable. And say you have 10,000 observations, just as an example. Then what do? We split the data into training data and test data. Why am I putting test data very far away? Because I need to explain another concept here. I need some space. Okay, training and test. Usually when you split the data randomly. You randomly split the data into training and test. And when you do that, usually we take 80% of data into training and 20% of data into test. It could be 70%, 30%, 60%, 40%. That's okay. That's left up to you. But ensure that you have minimum 50% of data in training. If you have more data in training, okay, I'll get to that later. Let me not confuse. Okay, randomly when you split it, you'll get the training data and test data. So let me put down the training data here. You have your output variable and 4 input variables. You have all these input variables. And since you're randomly choosing, you randomly choose, say, row number 2, row number 3, row number 5, row number 7, so on and so forth. When you count these 1, 2, 3, 4, 80% of this will be 8,000. So you'll have 8,000 entries. And data or the rows which are not part of your training data will be part of your test data. So you again write down y, x1, x2, x3, x4, x1, x2, x3, x4. And here row number 1, row number 4, row number 6, so on and so forth you'll have. So 1, 2, 3 in that way until 2000. Okay. 20% of 10,000 is 2000. So you randomly have. Whatever is not part of training will be part of your test. Now, when people keep saying, right, people keep saying that build a model. Building a model means you will learn the patterns between Y and X. Say this is age is 32, gender is female, income is 10,000 rupees per month, educational qualification is graduation. This person defaulted on the loan. This pattern is learnt. Then person is 42 years, male, uh, 28,000 rupees per month, postgraduate, will not default. I mean, the person repaid the loan. This person did not repay the loan. In this way, you look at all the various inputs and Given these inputs, what is your output? Given these inputs, what is the output? Given these inputs, what is the output? So you are in some sense learning the patterns between y and x. You're establishing the patterns, you're learning the patterns between y and x. Okay, you're learning the relationship, you're learning the patterns between y and x. When I say you're learning the relationship or patterns between y and x, all I say is you are going to establish the mathematical equation or mathematical relationship between y and x. Okay, we are learning the mathematical relationship between y and x. When I say you're learning the mathematical relationship between y and x, you come up with an equation, some equation. Different algorithms have different ways, right? And if you're building a neural network algorithm, then what will happen is you'll have an equation like this. Y is equal to b plus w1 x1 plus w2 x2 plus w3 x3 plus w4 x4. And when I say we built a model, all I'm saying is I've established the mathematical relationship between y and your inputs using this equation. This is my model. Where is your machine learning model? This is my machine learning model that I've built. Is this good or bad? How do you know? Is this good or bad? To comment on that, what we will do is we will first take all the inputs from here, x1, x2, x3, x4. Take these inputs and substitute in this equation x1, x2, x3, x4. These will be numbers. B, W1, W, all those will be numbers. X1, X2, X3, X4, you take from here only the inputs. Take only the inputs, substitute here, and then you'll get something called as predicted value. Once you get the predicted value, compare that with the actual value. Compare that with the actual value. Predicted value, actual value. Compare these two. Say your model predicts that, hey, this person, given this age, gender, income, and education, will default on the loan. Then you look at this actual value and say this actual value also says, yep, person defaulted in the past. So your prediction is similar to your actual values. Then this is a correct prediction. Then take the next row, take all these inputs and substitute in your equation. When you substitute these inputs in the equation here and solve it, you get a predicted value. Say the predicted value says person will not default. And then you look at this corresponding value, actual value. Say the actual value also says person will not default. So it's again a correct prediction. Then again take the next row. Take all these inputs, substitute in this equation, and then you get a predicted value. This time say person says, your model says this customer will not default. Look at your actual value here and then compare it. Say this actual value says person will default. Then there is a mismatch, incorrect. If you have an incorrect prediction and correct predictions, you count how many times you have correct out of total correction. So how many such values will you have? 2000. 1, 2, 3, 4, 2000. So 2000 entries is what you'll get. 1, 2, 3, in that way you'll have 2000. Take all those 2000, count how many times it is correct. So to calculate the accuracy, you count how many times you have correct. Say you have correct in 1800 places out of total 2000. And when you multiply it with 100, you'll get the accuracy percentage, which will be 90%. And this accuracy percentage you're getting is something that you're getting based on the test data. Hence, it is called as test accuracy. Go back to your training data. The model that you built using your training data, now test it on the same training data. You might say, if I test it on the same training data, will I not get 100%? No. Why? Because you have 8,000 rows here and we are coming up with one equation which is generic to all these 8,000 patterns. For each row, we are not coming with a different equation. We are coming up with a generic mathematical equation which will capture the relationship between y and x based on all these 8,000 observations. Okay, based on all these 8,000 observations. So you have 8,000 observations and you have these. Now, you take the inputs, substitute in this equation, and then once again you'll get a predicted value. Predicted value always has a hat on the top. So you get the predicted values. Say the predicted value says for this first entry that person will default. Then take this actual value and say actual value also says person will default. So you compare these two. Is this a correct prediction? Yes. Then take the second row. Take all these inputs and substitute in this equation and you get predicted value. This time say the predicted value says person will default. But then when you look at the actual value here, actual value says person will not default. Is there a match when you compare? No, there is a mismatch. Look at how many times you have correct. How many will you get total? 8,000, right? Look at out of these 8,000, how many times did your model correctly predict? Say it correctly predicted 6,000 times. Out of total 8,000. You divide these two, multiply it with 100% and you get percentage, right? 0.78 or 78%, something on those lines, if I'm not mistaken, is what you'll get. That is called as you're testing on the train and you're getting accuracy, right? This accuracy is called as training accuracy. This is test accuracy. This is train accuracy. Now what we do is, once we get all these things, I'll erase these. Just get rid of these and then I need to explain you guys about something very, 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 very interesting. Yeah, and that very, very interesting thing is, so you have your training accuracy here and you get your test accuracy here. Now compare these two. If these two are high, accuracy values should be high and close to each other. Okay, then it implies that This is a right fit. And then if your training accuracy is high and if your test accuracy is low, okay, if your training accuracy is high and if your test accuracy is low, then this is called as overfitting. This overfit is also called as variance. Then if your training accuracy is low, then obviously your test accuracy also will be low, and this is called as underfit or bias. Let me give you an example of sample papers. When students prepare for exam, 80% of the students are like one day batting. That's what they keep saying, one day batting. Yeah, in that one day batting, they get hold of all these sample papers. Agarwal, hope that rings a bell. Agarwal sample papers, right? They get access to the sample papers and then they work on sample papers. If you studied sample papers and say you're preparing for some entrance exam rather than engineering, let me take entrance exam example. So if you take all the previous sample papers and then you look at the question, and in the question if there is some number, then you know that answer is A out of ABCD. Then another question, if you have a specific word in the question, you know that answer is B. You didn't learn the logic, you by-hearted everything word by word. The sequence in which you have the multiple choice answers, everything you have by-hearted. Assume if you by-heart to this extent, then what will happen? Next time when you take an exam on the same sample paper, the moment you look at the question, you know what is the answer. The moment you look at the question, you know exactly what is the answer. This, if you prepare in that way and if you take an exam, obviously you'll get high accuracy because you're preparing on the same papers and testing on the same papers. So you'll obviously get high accuracy. In the main exam, if the questions are tweaked a bit, then you fumble, then you go wrong. So you're in the main exam, you'll get less score. This problem is called as overfitting or variance, meaning you overdid something. That's overfitting. This is a problem. And you fix this overfitting or variance problems using something called as regularization techniques. Okay, regularization techniques. Remember, for now, we will discuss all these later. Second most important thing is, or let me first explain about underfitting. Okay, if you did not even prepare well on your sample papers, then obviously you will not get well, right? If you did not even prepare well, if you're not getting good marks on your sample exam, in the main exam you'll have obviously not get good marks. This is called as underfitting. You did not even prepare well. To prepare well, what should you do? You go train properly. You take more sample papers, so get more data, get more rows, more columns, and then train it again, right? You didn't train properly, that's it. This is a small problem, but overfitting is a big problem. Okay. And a scenario wherein training accuracy is low, that means when you have taken exam on your sample paper, you didn't do well, but in exam you have done exceptionally well. Does such a scenario ever exist? No. Until unless you do some kind of cheating, or until unless you are probably blessed with some superior luck, you cannot get into this. So this scenario doesn't exist. Okay. So right fit, overfit, underfit. In the mind map, everything is clearly given, friends. Okay, don't worry. If you're not able to understand this, then all you need to do is just open the mind map and all of these things are given. I'll do a recap on the mind map, then you can see that. Okay. There is one important topic before we proceed, before we wind up for the day. Please pay attention. When you build your model on the training data and when you test on the test data, say you got an accuracy of 72%. And maybe you're not happy with this accuracy. So what do you do? With this information which you received from the test data, go back. Okay, go back with this information that you received. How did you receive this information? By testing on the test data, right? With this information, go back and then do one thing. You make changes here to your model that you're building, and those changes are called as hyper parameter tuning. Hyper parameter tuning. Very simple. You got low accuracy, so you want to go back, you want to do some changes. Those changes are called as hyperparameter tuning. Then again build your model, come back, test on your test data. This time maybe your accuracy increased to 78%. Again, with this information that you get from the test data, go back with that information. Again, tweak your hyperparameters, do certain changes, build your model, and again come back and test on your test data. This time maybe accuracy is 84%. With this information that you get from the test data, go back, again make changes to your hyperparameters, then again build your model and test. This time say accuracy has become 79%. Oops. So you stop here. You say that this is the best hyperparameter setting for which I get the highest accuracy. So I don't want to go any further because accuracy is decreasing. And you stop here and say that this is the best model. But then what would happen is there are two schools of thought. One school of thought says you take your data, split into training and test, build your model on the training and test on the test data, and you'll get some accuracy. Another school of thought says that this is called as information leak. This is something like, say there is a student who is who has prepared for the exam. He came to take the exam. In the test, he understood that he will not get more than 72% because for certain questions he doesn't know the answer. So he will say, sir, can I go to washroom? They go to washroom, where they again go open the book, read the answer solution, again they come back and then they continue with the exam. Now the student is certain that he'll get 78, but for a few other questions again he's confused. He says, sir, can I go out for drinking water? Then what they do, they quickly open the book, again they look at that, again come back and take the test. If they keep doing in this way, can you rely on this accuracy? Can you rely on the percentage that they get in the exam? No. Hence what people do is They say that this is called as information leak. We cannot quite rely, and hence we have to do something else. And that something else is that they split the data now. The second school of thought, what they do is they split the data now, which is the training data, into 60% randomly, and that 20% is taken into another data set called as validation data. Validation data. And this test data is kept very different. You'll not even use this test data once. So what happens is you build a model. The moment you build the model, test it on the validation data. Say you got an accuracy of 72%. You're not happy with this, assume. Then with this information, you go back, tweak your hyperparameters, and then build your model, then again test on the validation. This time, say accuracy is 78%. Again, you go back, tweak your hyperparameters, again build your model, again test on your validation data. This time, say the accuracy became 81%. Again, go back, tweak your hyperparameters, again build your model, again test on the validation data. This time, say accuracy becomes 79%. So you stop here and say that these hyperparameter settings are the best settings for me in this context, so I will choose those. Now what you do is, whatever hyperparameters have been used to achieve 81% accuracy, use that model and now test it on the test data. And you should ideally get around 81% when you test on test data. Accuracy should be around this. If it is around this, then good. You're good to conclude. If it is not around that, again you have to do certain other changes, which we'll discuss later on. Okay, fine. Hence we will have, so 20% of data here. Hence we say that we have training data, validation data, and test data. Well, say here also you got say 82%. Say you're happy with this, right? You're happy with the accuracy. Now one more final thing that we do is, once you figure out that these settings are giving the best result, take those settings and build one final model on the entire data. So you finally go back to this data here. And using these hyperparameters, build a final model and use it for prediction on new values, new observations, or new inputs. The moment you get the new observations or new inputs, use that for your prediction purpose. Okay. Hope this is making sense. And prediction on new observation, and then you finally deploy your model in production. Okay, so let us do a quick recap. So The first step is understanding the business problem, wherein you understand the business objectives and business constraints. Record those. Very important. Then what do? You need to move to the next step, which is data collection. Before that, you need to understand the various data types, such as continuous, interval ratio, discrete, categorical count, qualitative, quantitative, structured, unstructured, big data, not big data, cross-sectional, time series, longitudinal, balanced, imbalanced data sets, batch processing, and time series. Once you're done with this, once you understand the in and out of the various data types, you will have better confidence to proceed further with data collection. And as part of data collection, you have primary and secondary. Primary data collection, first you go after secondary data collection. Only if you do not have the data here, you go after primary data collection. Then the data which you have collected need not necessarily be in the right format, right? I mean, data need not be very clean, etc. So what you do is you perform data cleansing, data preparation, exploratory data analysis, feature engineering, bunch of those. And a lot of these terms are overlapping terms. Once you have the data which is proper, you proceed further with data mining, and you do supervised learning and unsupervised learning. We will remove all these, these are all your typical unsupervised learning. Only for deep learning, whatever are unsupervised, we'll mention only those. Once you are clear with this, you evaluate your model. Here is where we learned about machine learning primer. In machine learning primer, you take your data and split your data into training, validation, test. Usually what people do is they take 60% of the data into training, 20% into validation, and another 20% into test. You train your model, I mean, build your model on the training data, and then first test it on the validation data. Why? Because you want to tweak your hyperparameters and decide on which set of parameters are giving you the best results. And as I've told you, auto ML is coming in a big way, and you have a technique to automatically tune your hyperparameters. You need not worry. Once you figure out that these are the best hyperparameters, then you take your model and test on the test data. So test on this test data after getting the right set of parameters. And then you get either accuracy or error. If you get testing error is also called as generalization error. For example, if I say accuracy is 72%, then error would be 28%. Simple. What is the relationship between accuracy and error? Accuracy percentage plus error percentage will be equal to 100%. It will be equivalent to 100%. If the accuracy is 72% and if you have some error, or error would be 28%. Both when you add, it should be equivalent to 100%. Simple. If I say accuracy should be high, what should be your error then? Error should be low. Simple. If accuracy should be high, error should be low. That's the correlation. Okay. So you get generalization error. Testing error is also called as generalization error. And then you compare the training error and test error or accuracies. If both the errors are low and close to each other, it is called as right fit. If training error is low and if testing error is high, then it is called as overfitting or variance regularization techniques. Okay. I mean, if it is overfitting, you apply regularization techniques to fix this problem. If both training error and testing error are high, it is called as underfitting or variance. You get more data. That's it. You try to get more data observations. It will solve your problem. Okay. So these are the things that we discussed, and we are also in the next session. It will not take a lot of theory henceforth. We will learn about model accuracy measures. What do you mean by loss function and cost function? What are the various regularizers? And then we will switch gears to mathematical foundations, basic math, which is needed for you for understanding the AI algorithms. And then we'll jump into deep learning primer. And I would say another 2 days, that is Monday and Tuesday. And from Wednesday onwards, it'll be 50-50%, 50% of theory, 50% of practicals on Python. We will take real world use cases and solve. Okay. All right. So let me quickly type here on what all you learned. So we discussed today about machine learning primer. We continued from where we have left yesterday. And today we learned about the data types. We then discussed about um data cleansing, or I would say data preparation and feature engineering, wherein you have the input variables and you make certain changes to that. Then we have also discussed about data mining or machine learning, in which obviously you will have supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, etc. And then you enter into we entered into machine learning primer, wherein we know on how to split the data into training, validation, and testing. And then we discussed about how to compare the various accuracy values or error values comparison to understand what do we mean by a right fit, what do you mean by an overfit or variance. And we discussed that we use regularization techniques to solve it, and underfit or bias, just get more data, simple, to solve this problem. Okay, this is what has been discussed. With this, I'm going to give you a few links as usual. No, we don't have sessions on weekends. We'll have sessions from Monday to Friday. Both, Ramakrishna, you can either use this or that. Yeah, feedback form is okay. Even before that, quick things. Let me choose this and let me write it here. Click on the link on sticky note to fill the details. to get access to our learning management system, which is called as AI Spry. Okay, very important. Okay, please, this is the first important thing. Let us do this first, then we can answer the other things. And the LMS registration link is given here. What will this learning management system contain? Training slides, data sets, Python code, and quizzes. Training slides, data sets, Python code, and quizzes. Okay. By when will you get? You're going to get access before Sunday. Please check your spam folder also. Please check your spam folder without any miss. I wish to highlight this. Spam folder also you need to check, because without checking this, I'm sure a lot of you all will get back to us saying that please, I didn't get. No, we will not miss out even on a single person. We will send to everyone who has registered. People who are not attending, we obviously, how can we give access, right? So if you're not attending, just because you're, I mean, whoever is attending, right? Just because you all get access, other people will want to get access. They'll start sending emails. No. And don't share your email ID password with anyone. If we observe that you're connecting from two different computers, two different places, your account will automatically get blocked. And we cannot unblock it. So please don't do that. Okay. I'm sure we all will uphold the ethics, but this is the okay. For attendance also, form link is posted. Please give the attendance, and we will not push much because we need LMS. We need you all to get LMS access. So, yeah, two logins. If you're connecting from mobile, that's okay, Venkat. We will consider that. But same time connecting from two, both laptop and mobile, means you're doing something fraud. So in that way, our algorithm is devised. Yeah. So we will not manually do it. Our algorithm automatically does it. But if you're connecting from mobile at one time and laptop from another time, and the distance is within some 15 kilometers, then it will allow that. Ah, yeah, sure, Jiban. Amazing. All right, friends. Thank you so much. Have a great weekend. Just this recorded session will be there on our YouTube channel. Okay, I'm going to post that link. Also, where is it? Here. Yeah, I'm posting the link of the YouTube channel. Click on it, subscribe, share it with people. Don't worry, and let's enjoy. Pleasure. Okay, you all must be feeling hungry. Go have good food. Thank you. Have a good weekend. Stay safe. Thank you all, friends.